Hi class, today we have the 21st class for differentiation of calculus, but this is the third example for implicit functions. The problem is to find dy dx in terms of x and y, meaning our final result will still contain x and y. When we have x squared plus y squared minus 2xy plus 3y minus 2x equal to 7. Yes, so I will still repeat by saying, how do we know that this one is an implicit function? One, when the highest power of the, when the highest power, when the power of not highest, when the power of y is more than 1. There are 2 or more, just that one, it means the function is an implicit function. The second point is when we have a term that contains xy, when we have a term that contains what? Xy. So that one again makes it what? An implicit function. Okay, so now that we know this one is an implicit function, there is something we have to do that we don't do in normal functions. All right, this is x squared. X squared is just as usual. We are in the power multiply the coefficients. Here is 1. So 2 times 1 is 2. Then the power minus 1, there will remain 1. But it's not necessary to write 1. Plus y squared. What do we do? Y squared. The same thing. Here is 1. 2 times 1 is 2. 2 minus 1 is 1. We write the power. But the difference between implicit functions and the normal function, for implicit function, whenever you differentiate y, you're supposed to attach dy dx. We did not do that here because the rule is not for when you differentiate x. The rule is whenever you differentiate y as usual, then you attach dy dx. Now this one here, we have minus 2xy. Minus what? Minus 2xy. Whenever you have a term that comprises x and y, you differentiate that term twice for implicit function. There are 2 things you do. When you have a term that comprises xy, you differentiate it twice. When you differentiate y, you attach dy dx. Now we have minus 2xy. Minus 2xy. We want to differentiate this. But you do it one at a time. You differentiate x, later differentiate y. If you want, you start with y, later x, no problem. Now let us say we want to differentiate what? X. We want to differentiate what? X. So if we want to differentiate x, what do? Let us assume y is not there, or let us keep y aside so you don't get confused. I hope you get my point. We are here, the term that comprises xy. We must differentiate it twice according to implicit function system procedure. So we want to start by differentiating x. So let us keep y aside. We'll bring it later. So if we differentiate this, what do we get? We get minus 2. We all know that minus 2x, you differentiate it, we get minus 2. So now you can bring this one. You keep it. You first kept there. So we have minus 2y. Can we add dy dx as we did here? No, because we differentiated x and not y. We have differentiated x. Now we are coming to differentiate what? Y. Look at the same term, minus 2xy. We want to differentiate what? Y. Let us keep x. Let us keep x. If we differentiate minus 2y, what do we get? We get minus 2. Just like minus 2x gives minus 2, minus 2y gives what? 2. Minus 2. The only difference is once you've acknowledged the function is an implicit, whenever you differentiate y, you attach dy dx. But don't forget that we kept x. So this is minus 2x. Even when we differentiated x earlier, the y we kept, we brought it later. So now again, we keep what? X. We differentiate this to give us minus 2 dy dx, we bring x. So minus 2x dy dx. I hope it is clear. So if you differentiate plus 3y, we get 3. Just like if you differentiate 3x is 3, 10x is 10, minus 5x minus 5. But this is why we differentiated. So we must add dy dx. Minus 2x, we differentiate, what do we get? Minus 2. Can we add dy dx? No, because it is not y. Equal to, differentiating a constant will give us 0. We want to find dy dx. So let us collect all the terms containing dy dx. This is 1, 2y dy dx. Here is another, minus 2x dy dx. Here is a third one, plus 3 dy dx. We are done with the terms with dy dx. Those without the dy dx, they go to the other side. Starting this will go with minus. So let us start with the negative here. This minus 2 goes with positive 2. Now this now can go with what? Minus 2x. This goes with what? Plus 2y. I hope it is clear. This moves with positive sign, goes there with negative sign, goes there with positive sign. So we need dy dx. So we say dy dx. Okay, this takes away this leaving 2y. This takes away this leaving minus 2x. This takes away this leaving plus 3. We factor out dy dx. So 2 minus 2x plus 2y. But we need only dy dx, so we divide both sides by this expression. 2x plus 3, 2x plus 2y minus 2x plus 3. So this goes. So our dy dx is equal to, if you want, you can factor the 2 that is common, but it's not necessary, because if it would have been possible here to have a factor of 2 that will be cancelled later, that would have been nice. So 2 minus 2x plus 2y, 2y minus 2x plus 3. So we've gotten what? Dy dx in terms of x and y. So you see, the result comes with x and y. Thank you for watching. Don't forget to follow, like, share, and comment.